Good morning, afternoon, evening, wherever you are logging to this session. So, welcome to this presentation on NVIDIA Gen AI Complete Ecosystem, a comprehensive platform designed to accelerate the development and deployment of generative AI application. So, we'll explore the different layers of this ecosystem with the component and application in the next few slides. Introduction to NVIDIA's Gen AI ecosystem. So, NVIDIA offer a full stack of accelerated complete platform based on either a current generation Hopper or the future the Blackwell, purposely built for generative AI workload. The platform is both deep and wide, offering a combination of hardware, software, and services, all built by NVIDIA and its broad ecosystem of partners. So developer can deliver cutting-edge solution in an accelerated fashion for a large and extra large models. So let's look at the layering of this platform. So there are four main layers, and under each of this main layer, there are sub layers. These sub layers sometimes overlap. The component from the sublayer overlap between some of the main layers. So let's look at the main layers and their sublayers. So the top layer is the domain specific and generative AI application system. It has two sublayer. One is the system and applications, as well as the services and the microservices. The So then the next model is the model customization, evaluation, safety, and examinability. That have got two sub layers. Is called model and SDK and framework. So these also sometimes overlap with the microservices as well. And then the next one is actually model architecture and the techniques. It have got two sub layers: SDK framework and libraries. And The last one is the bottom one is actually the system optimization. Have got T suppliers, the libraries, uh, management and orchestration, and also accelerated infrastructure. So this is actually a kind of a overall summary view of the main layers and the sub layers. So here I think we are looking at specifically detail on this domain specific and the generative AI application system, which have got two sublayers: systems and application, and service microservices and services. So the system and application, the NEMO offers a rich ecosystem tools and framework to streamline the development process. Popular choices include LangChain for orchestrating workflows, Llama Index for knowledge management, and weights and bias for experiment tracking. Then the then we have domain specific one. We have for specific domain like healthcare, finance, and more. Nemo provide pre-trained models and tools for expert development. Um, and also we have the for model like offering from a third party like AWS Bedrock, Azure ML, and uh, others for other cloud providers as well. And the services, microservices area, we have the Nemo microservices architecture enable efficient deployment and scaling of AI application. Consider using NVIDIA's NIM, which is actually NVIDIA's inference microservice for model inference, and Avatar Cloud Engine ACE for conventional AI. So these are some of the component in that domain specific and generative application system areas. Let's look at the second layer: model customization, evaluation, safety, and explainability. So there are two layers of layers like a models and SDK and framework. So in the model side, we have the rich set of models like Bloom, Llama, Mistral, MPT, Pi2, Getty Image, AI generator, Shutterlock, 3D generator. Um, and also from a NVIDIA side, Biomegatron, Edify, Nemotron. And then from SDK and framework, we have a Hugging Space, Transformer, PyTorch, and then NVIDIA A2X, Megatron LM, Nemo framework, and Riva, and also Picasso. So these are just a few, and then there are more. It's complete, continuously adding as well. So look at the third layer. We have the model architecture and techniques. So we include like a um, stick and framework libraries, and but also there is some found models also come into play. So that it's like from a again from ecosystem standpoint, we have Hugging Space, Transformer, PyTorch, NVIDIA, A2X, Megatron, LM, Nemo framework, and Riva Picasso. On the libraries ecosystem, we have the CUDA, XLA, Cutlass, uh, so Megatron Core and Megatron etc. LM etc. And also NCCL, Raft, Transformer Engine, and TensorRT LLM Ray. These are some of the um, libraries available on this um, model architecture and technique layer. So let's look at the bottom layer, which is a system optimization layer, which is mostly the infrastructure and some tool. So the bottom layer where we have the GPU, DPU, and also the InfiniBand switch which connect GPU, multi GPU connection. And then we have the management and orchestration ecosystem where Kubernetes, Slurm, VMware, and also we have the NVIDIA from Maze Command Platform. And then we have the other, we already covered the libraries where we have the CUDA, Megatron Core, Megatron LM, and also Transformer Engine, TensorRT, LLM, Ray, etc. So these are the system optimization layer of the bottom of the stack. So let's look at the overall what we learned so far. As we went through, we have the overall picture of the all layers. We have the seven layers here, starting from the system optimization, which have the accelerated infrastructure, which the NVIDIA's DPU, GPU, and InfiniBand to connect the multi GPU system. And then we have the management and orchestration, where we have the Kubernetes and also VMware VM virtualization, and also we have from a NVIDIA based command platform. Then we have the library for abstracting the GPU, which is like CUDA, um, Cutlass, and also and NCCL, Transformer Engine, TensorRT, LLM, Ray, etc. So now come back to the model architecture and techniques, where we have the sublayers of SDK and framework, where ecosystem including Colossal AI, Hugging Space, Transformer, PyTorch, and NVIDIA side A2X, Megatron LM, and Nemo framework, and also Rivia and Picasso. On the model standpoint, we have the model customization, evaluation, safety, and explainability. The rich set of ecosystem like a Bloom, Llama, Mistral, MPT or PT, Py2, Getty Image AI generator, Shutterstock 3D generator, NVIDIA's Biomegatron, Edify, and Nemotron. And then from the top, domain specific and generative AI application system, where we have the service and microservice, where we have a rich set, the cloud providers like AWS Bedrock, Azure ML, and Cohere, and Google Vertex AI, and OpenAI AI. And the NVIDIA side, we have the NIM, Avatar, Cloud Engine AC, BioNemo, and Nemo, and Picasso. On the system and application side, we have the agent kind of a chain, like a long chain, Llama Index, Weight, and Baz, NVIDIA AI Workbench, and Nemo guardrails. So this give you the end-to-end view of the main layers and also the sub layers. Thanks for joining the session today. Hope you learned more about NVIDIA's end-to-end ecosystem to build a GenAI application from infrastructure of GPU to the model training and fine-tuning to deployment both on-premises cloud and workstation. So I've also put a link here for NVIDIA's developer page where you can explore more and start building your GenAI application with NVIDIA's ecosystem. Thank you.